Imagine wandering through forgotten forests, ruined hangars, and deserted roads of Europe and stumbling upon relics of a dark past. Abandoned Nazi vehicles, some rare, others incredibly strange, that seem taken out of a science fiction movie. From experimental tanks to prototypes that never saw the war, these machines tell stories of military engineering, warlike obsession, and secrets that time almost managed to bury. Today, we will show you the 20 strangest Nazi vehicles ever found, a journey through the mechanical remains of a regime obsessed with war and extreme innovation. The 20 most strange abandoned Nazi vehicles ever found. BMW R75, with sidecar, the all-terrain machine of the Wehrmacht. The BMW R75 with sidecar was one of the most emblematic vehicles used by Nazi Germany during the Second World War, a symbol of mobility, versatility, and technology applied to the battlefield. Designed by the Bavarian brand Bayerische Motorrennwerke in 1941, the R75 was not a simple motorcycle with an attached sidecar, but a war machine specifically intended to withstand the extreme conditions of the front. It was not an improvised adaptation, but a military project from the beginning, commissioned by the German High Command with the objective of providing its troops with a light, fast, and functional vehicle. The R75 had a Boxer engine of 750 cubic centimeters, air-cooled, capable of developing about 26 horsepower, enough to reach speeds close to 90 kilometers per hour, even with load and on uneven terrain. One of its most revolutionary aspects was its transmission system. It had a gearbox with 4 forward gears and 1 reverse, something unusual for a motorcycle of the time. In addition, it was equipped with traction on the sidecar wheel, which gave it a surprising ability to move in difficult terrains such as snow, mud, or sand. In practice, this turned the R75 into a hybrid between a motorcycle and an all-terrain vehicle. The design of the sidecar was not a simple extra seat. It was conceived as a tactical extension. It had space for a third soldier, could transport heavy weaponry, ammunition, and even mount a MG-34 or MG-42 machine gun, which allowed it to serve as a mobile fire platform. This made the R75 an extremely versatile unit. It could function as a reconnaissance vehicle, troop transport, improvised ambulance, or combat support weapon. The sidecar even incorporated a drive shaft connected to the motorcycle, which made it an active part of the traction system and not a simple addition. The German troops deployed the R75 in multiple scenarios, from the vast Soviet steppes to the deserts of North Africa. Its robustness and ease of maintenance made it a reliable tool, capable of operating under extreme temperatures and in hostile landscapes. However, like every German precision design, it also had a disadvantage. It was complex to produce and expensive compared to the Allies' motorcycles such as the Harley-Davidson WLA or the Soviet M72, which was practically a copy of the German model, the result of previous agreements between Berlin and Moscow before 1941. Despite these limitations, the BMW R75 with sidecar became an icon of military mobility of the Third Reich. It was employed by reconnaissance units, paratroopers, panzer divisions, and above all by the Waffen-SS, who used it both in combat and in patrol and control operations in occupied territories. Today, the R75 is a highly appreciated collector's item for enthusiasts of military history and classic motorcycles. Its legacy lies not only in its effectiveness as a war vehicle, but also in the level of engineering achieved, which marked a before and after in the development of military motorcycles. STKFZ-2 Kettenkrad, the strange tracked motorcycle of Nazi Germany. The STKFZ-2, popularly known as Kettenkrad, was one of the most singular and versatile vehicles deployed by Nazi Germany during the Second World War. Halfway between a motorcycle and a small tracked tractor, the Kettenkrad combined mobility, endurance, and power in an unconventional design that made it a valuable tool on the toughest fronts of the conflict. Its appearance, with the front part similar to that of a conventional motorcycle and the rear part equipped with a track system, gave it a unique functionality, capable of moving in terrains where other light vehicles simply could not advance. It was originally designed by the company NSU Motorrennwerk in 1939 with a specific purpose: to serve airborne troops. Its compact size made it ideal to be transported inside airplanes such as the Junkers Ju-52 or launched in gliders, which allowed paratroopers to have a motorized vehicle immediately after landing. This capacity made it a valuable resource during the first phases of the war when the blitzkrieg depended on fast mobility and tactical surprise. The Kettenkrad was equipped with an Opel engine of 1,478 cubic centimeters, the same used by the Opel Olympia automobile, capable of producing 36 horsepower. With this engine, it could reach a maximum speed close to 70 kilometers per hour on the road, although its true value lay in its performance on difficult terrains. Thanks to its track system, it could climb slopes of up to 24 degrees, cross muddy areas, snow, sand, and even overcome moderate obstacles that would have stopped a motorcycle or a light automobile. For steering, the Kettenkrad used the typical front handlebar of a motorcycle, but in sharp maneuvers, the tracks came into action through a system of differential brakes, which gave it surprisingly precise control for its size. On the battlefield, it fulfilled multiple functions. It was used for the transport of soldiers and supplies in areas where trucks could not reach, to tow light artillery pieces, mortars and small-caliber anti-tank guns, and even to drag damaged airplanes within airfields. Its towing capacity reached up to 450 kilograms, and at times it was used as an auxiliary tractor for anti-aircraft artillery. On the Eastern Front, especially in the extreme conditions of the Russian winter, the Kettenkrad became an essential resource since it maintained troop mobility when snow immobilized other vehicles. Beyond its role in combat, the Kettenkrad also found uses in logistics and communication. It was used to quickly lay telephone cables at the front, to transport ammunition to forward positions, and even as a reconnaissance vehicle in complicated terrains. Its small size and low silhouette made it more difficult to detect than a truck or an armored vehicle, which made it a discreet but effective means. Although it was an extremely useful vehicle, the Kettenkrad could not be produced in large quantities due to the complexity of its design and the priority of other military programs. Between 1940 and 1945, about 8,300 units were manufactured, a relatively low number considering its effectiveness. After the war, many surviving units were reused for civilian tasks, especially in agriculture and forestry in Germany, where its traction and compact size were perfect for working in forests and mountainous terrains. Its versatility allowed it to remain in use during the post-war period, and today it is a highly sought-after vehicle by collectors and military museums, a symbol of German technical capacity and its obsession with creating innovative machines, even if they seemed strange at first sight. Volkswagen Schwimmwagen, Hitler's amphibious car. The Volkswagen Schwimmwagen was one of the most curious and ingenious vehicles of the Second World War. Designed to move both on land and in water, it became the most produced amphibious vehicle in all of history, with more than 14,000 units manufactured between 1942 and 1944. Its compact and peculiar appearance, similar to a small all-terrain car, concealed an impressive versatility that made it especially useful on fronts where mobility was everything. The Schwimmwagen was born from the Kugelpanzer, the light automobile that Ferdinand Porsche had designed for the German army as a kind of German Jeep. At the beginning of the war, German engineers saw the need for a vehicle capable of crossing rivers and swamps without the need for bridges or pontoons, especially considering campaigns such as the Eastern Front, where natural obstacles could slow the advance of entire divisions. From that idea, the Schwimmwagen was developed, whose body was completely redesigned to make it watertight and navigable. It was powered by the same engine as the Kugelpanzer, a Volkswagen Type 1 with 4 cylinders and 1,131 cubic centimeters, which generated about 25 horsepower. It could reach a maximum speed of 80 kilometers per hour on the road and about 10 kilometers per hour in the water. For aquatic propulsion, it had a propeller located at the rear, which folded down when entering the water and connected directly to the engine. Steering, instead of using additional rudders, was done through the front wheels, which acted as a rudder when turning. This simple but effective system allowed the Schwimmwagen to quickly pass from land to water without the need for complex mechanisms. Its body was built in a single piece, boat-shaped, to ensure buoyancy and prevent leaks. It had total traction in the four wheels, which gave it excellent performance on difficult terrains such as mud, snow, or sand, something fundamental on the Russian front and in Africa. In addition, its light weight of just over 900 kilograms allowed it to move with great agility, which made it a much superior all-terrain vehicle to many others of the time. The Schwimmwagen was used mainly for reconnaissance, exploration, and light transport in areas where rivers, streams, and swamps complicated military operations. It also served as a link to carry messages, escort convoys, or transport officers through terrains where a conventional vehicle would get stuck. Although it was not designed for direct combat, its ability to move on any type of surface made it a very appreciated resource for reconnaissance units, engineers, and special troops. On the Eastern Front, especially during thaw periods and in the vast swampy areas of Ukraine and Belarus, the Schwimmwagen proved invaluable. In Normandy and other Western fronts, it was also used in patrol and reconnaissance missions, taking advantage of its ability to cross rivers quickly without depending on bridges. Despite its ingenious design, the Schwimmwagen had limitations. Its small size did not allow it to transport more than 4 soldiers and a light load, and its armor was non-existent, which made it vulnerable to any enemy attack. Even so, it fulfilled what was expected of it: mobility, speed, and adaptability. After the war, many captured units were used by Allied armies and in civilian uses, especially in rural regions with rivers and lagoons. Today, the Schwimmwagen is a true collector's item, highly coveted for its rarity and for being a symbol of German engineering applied to the needs of war. Its legacy remains as a reminder of how, in the midst of the Second World War, the search for innovative solutions led to the creation of unique vehicles capable of adapting to almost any challenge of the terrain. Kugelpanzer, the mysterious spherical tank of Nazi Germany. The Kugelpanzer, also known as sphere tank or ball tank, is one of the most enigmatic vehicles of the Second World War. It was a German prototype of which little is known with certainty, and its mere appearance makes it a rarity within military history. Unlike any other known armored vehicle, the Kugelpanzer had a spherical shape and was designed to move on 2 large wheels that covered its entire structure. Its design seems taken from science fiction, but it was a real creation, captured by Soviet forces in 1945 and later exhibited in the Kubinka Tank Museum in Russia, where it is still preserved. The origin of the Kugelpanzer remains a mystery, as there are no official documents detailing its design, production, or use in combat. It is believed to have been manufactured by the German company Krupp, one of the industrial giants of the Third Reich, specialized in armament and military vehicles. Only one known example was built, which reinforces the idea that it was an experimental prototype, perhaps never put into active service. The vehicle measured around 1.5 meters high and was covered by armor of barely 5 millimeters thick, sufficient only to protect the occupant from light weapons or shrapnel, but incapable of withstanding heavy fire. It weighed about 1 ton with 800 kilograms and moved thanks to a small motorcycle engine of about 25 horsepower. It was not fast, with an estimated speed of 8 kilometers per hour, but neither did it seem to be designed for direct engagements. At the rear of the Kugelpanzer, there was a smaller stabilizing wheel that allowed it to maintain balance, while the interior only had space for 1 crew member. The cabin had a narrow front slit for vision, which indicates that the pilot operated in an extremely reduced space. As for armament, there is no clear evidence that it was equipped with cannons or machine guns. It is probable that it had only been planned for reconnaissance tasks, advanced observation, communication cabling, or even as a support vehicle for artillery units. Some historians suggest that the Kugelpanzer could have been conceived for sabotage, infiltration, or exploration missions in difficult terrains where its small size and rounded shape made it harder to detect. Another theory suggests that it was designed to accompany larger tanks, serving as an observation or liaison vehicle between units. However, due to the lack of documentation, all these hypotheses remain speculations. What is known is that the prototype was captured by the Red Army in Manchuria in 1945, which indicates that the Germans had delivered it to the Japanese, or that it had been sent to Asia as part of military cooperation between the Third Reich and the Japanese Empire. This clue reinforces the theory that the Kugelpanzer was not intended for European battlefields, but for a different environment, perhaps linked to operations in the Asian terrain. The mystery surrounding the Kugelpanzer is what has made it such a fascinating piece for military history enthusiasts. Being unique and without detailed records of its development, many consider it an example of how Nazi Germany experimented with unconventional designs in search of technological advantages. While other prototypes such as the Maus or the E-100 pointed to gigantic super-heavy tanks, the Kugelpanzer represented the opposite idea: a light, small, mobile and specialized vehicle. Today, the Kugelpanzer continues to be the subject of debate among experts and enthusiasts. Some see it as a technological failure, a useless machine without real application in combat, while others interpret it as a visionary attempt to create a new type of military vehicle ahead of its time but too experimental to be adopted. Its very existence is a demonstration of the diversity of projects that emerged in the last years of the war, when the Third Reich was desperately trying to find secret weapons that would change the course of the conflict. Landkreuzer P.1000 Ratte, Hitler's steel monster. The Landkreuzer P.1000 Ratte was one of the most excessive and ambitious projects conceived by Nazi Germany during the Second World War. Its name, which literally means rat, contrasted with its colossal dimensions, a super-heavy tank of 1,000 tons intended to be the largest armored vehicle ever built. Although it never moved beyond paper and a few initial sketches, its mere conception reflects the mentality of technological megalomania that characterized certain projects of the Third Reich. The Ratte was part of the Landkreuzer or Land Cruisers series, a concept promoted under the direct influence of Adolf Hitler, fascinated by giant weapons capable of symbolizing the Reich's power. The design was proposed by the company Krupp in 1942, the same firm responsible for renowned cannons and armored vehicles. Its size exceeded any practical parameter. With a length close to 35 meters, 14 meters in width and 11 meters in height, it was more of a mobile fortress than a conventional tank. Its monumental weight of around 1,000 tons placed it in a unique category, far above even other supertank projects such as the Maus, which barely reached 188 tons. To move such a monster, it was planned to install 2 man-naval diesel engines of the type used in U-boat submarines, capable of generating up to 17,000 horsepower combined. Even so, its maximum speed would barely reach 40 kilometers per hour, and its maneuverability would have been extremely limited. The planned armament was equally disproportionate. The Ratte was designed to mount a main turret similar to that of a naval cruiser, equipped with 2 SKC-34 guns of 280 mm, the same pieces used on warships such as the battleship Scharnhorst. Added to this were a secondary gun of 128 mm, several heavy machine guns, MG-34, and in some drafts, even anti-aircraft cannons of 20 mm and 37 mm to repel air attacks. In practice, it would have had the firepower of a Kriegsmarine warship, but transferred to land. The armor was also intended to be formidable, with plates reaching up to 360 mm in the most exposed areas, which would have made it practically invulnerable to most Allied anti-tank guns of the time. However, the cost of this protection would have been its mobility. Its enormous mass would destroy roads, collapse bridges, and hinder any attempt to move outside firm and wide terrains. The project was officially cancelled in 1943 by Albert Speer, Minister of Armament, who considered that such a machine was not only impractical, but also a waste of resources at a time when Germany was already on the defensive. The production of a single Ratte would have consumed materials equivalent to those necessary to manufacture dozens of smaller and more effective Panzer tanks, not to mention the logistical problems of transport, maintenance, and fuel supply. Even so, the Ratte was etched in history as a symbol of the delusions of grandeur of the Nazi regime. Today, the Landkreuzer P.1000 Ratte continues to fuel the imagination of enthusiasts, historians, and creators of fiction. Its design appears in video games, comics, and novels, where it is represented as the ultimate expression of mechanized warfare. Although it never existed beyond the plans, its legend serves as a reminder of the extremes to which German military engineering went in search of miracle weapons that could change the course of a conflict that in reality was already tilting against them. Junkers Ju-87 Stuka, the dive bomber that sowed terror. The Junkers Ju-87, known worldwide as Stuka from the German abbreviation Sturzkampfflugzeug, dive bomber aircraft, was one of the most iconic and feared planes of the Second World War. Designed by Hermann Pohlmann in the decade of 1930 and produced by Junkers, the Stuka was conceived for a very specific purpose: to destroy targets with precision through dive attacks. Its entry into combat not only marked a new stage in air warfare, but also became a psychological weapon that spread panic among those who heard it approaching. The Stuka was a monoplane with inverted gull wings, fixed and faired landing gear, a not very streamlined design that made it easily recognizable in the skies. It was not a fast or agile plane compared to contemporary fighters, but it compensated for those limitations with its ability to launch devastating attacks against ground targets. Equipped with a Junkers Jumo 211 liquid-cooled inline 12-cylinder engine, it could reach speeds close to 390 km per hour, which made it slow against enemy fighters but sufficient for its original mission of close air support. Its most distinctive feature was the dive bombing mechanism. The Ju-87 could tilt at angles of up to 80 degrees over its target, allowing the pilot to release bombs with unusual precision for the time. The aircraft was equipped with dive brakes under the wings, which reduced speed during the fall and prevented the structure from being damaged by the strain. After releasing the bomb, an automatic recovery system helped pull the plane out of the dive, protecting the pilot from losing consciousness due to G-forces. However, what turned the Stuka into a machine of terror was the addition of the famous Jericho sirens, a device installed on the landing gear that emitted a chilling howl when diving. This sound, designed for psychological purposes, created a devastating impact on enemy troops who often fled in panic even before the bombs struck. Later versions, such as the Ju-87G, were adapted as tank hunters, equipped with two 37mm cannons mounted on the wings, making it a formidable threat against Soviet armor on the Eastern Front. The Stuka entered active service in 1936 during the Spanish Civil War, where the Condor Legion used it successfully, convincing the Luftwaffe of its effectiveness. Its true prominence came in the campaigns of Poland, Norway, Holland, Belgium, and France between 1939 and 1940. On the Eastern Front, the Stuka regained prominence. There, pilots such as Hans-Ulrich Rudel, the most decorated of the Luftwaffe, turned it into a devastating tank-hunting weapon, destroying thousands of Soviet armored vehicles. Even in the last years of the war, when the skies were dominated by the Allies, the Ju-87 continued to be used in specialized roles, although increasingly relegated compared to more modern and versatile aircraft. At the end of the war, more than 6,500 units of all its variants had been manufactured. The Ju-87 Stuka was not a perfect plane, nor was it invincible, but its legacy transcends the technical. It was a weapon that combined innovation with psychological warfare, and that left an indelible mark on the memory of those who faced it. Its rough silhouette, its dive flight, and above all, the terrifying howl of its sirens remain, even today, a symbol of the power and terror of the German blitzkrieg. Panzer VIII Maus, the heaviest tank in history. The Panzerkampfwagen 8 Maus was the most colossal and ambitious tank project conceived by Nazi Germany during the Second World War. Its design was the work of Ferdinand Porsche, and it was born out of Adolf Hitler's obsession with creating giant weapons that would demonstrate the technological superiority of the Third Reich. The Maus was intended to be the ultimate tank, a mobile fortress practically invulnerable on the battlefield, capable of destroying any enemy armor and resisting any type of fire. With a colossal weight of 188 metric tons, it remains to this day the heaviest fully enclosed armored combat vehicle ever built. Its frontal armor reached thicknesses of up to 240 millimeters, which made it impenetrable to practically all anti-tank guns of the time. It was armed with a main cannon of 128 millimeters, KWK 44L/55, equivalent to the power of the Jagdtiger tank destroyers, accompanied by a coaxial 75 millimeter cannon to engage lighter targets. This combination of weaponry gave it a devastating capacity against both tanks and fortifications. The Maus, however, faced enormous practical limitations. Its size made it extremely slow, with a maximum speed of barely 20 kilometers per hour in ideal conditions. In addition, its weight was a critical problem. It was too heavy to cross most European bridges, which forced the design of alternative solutions such as deep fording with snorkels or the use of electric generators connected to another tank to move it in certain circumstances. Its mobility was so limited that, although in theory it was supposed to be invincible, in practice it was vulnerable to Allied air artillery, since its slowness made it an easy target for bombers and fighter bombers. The project began in 1942, and Hitler ordered its construction from Porsche with the expectation of producing hundreds of units. However, the war was turning against Germany, and the industry could not sustain such a colossal project. By 1944, only 2 prototypes had been built, one with a functional turret and another incomplete, limited to the chassis. None of them ever went into combat. Both were tested in Kummersdorf, near Berlin, and at the end of the war, the Soviets captured the remains. Russian engineers joined the parts of the 2 prototypes to create a complete Maus that was transferred to the Kubinka Tank Museum in Russia, where it is still preserved as the only surviving specimen. The Maus is remembered as an extreme example of the Nazi tendency towards the so-called Wunderwaffen, or wonder weapons. In theory, it represented ultimate armor and firepower, but in reality it was a logistical and strategic failure. Its cost, its impracticality on the battlefield, and Germany's lack of resources in the final stages of the war sealed its fate. It never entered combat and was relegated to the category of historical curiosity. Even so, its imposing presence made it one of the most famous pieces of German military engineering, and its figure has inspired video games, documentaries, and works of fiction that present it as a symbol of Nazi Germany's technological excess. Focke-Wulf Triebflügel, the impossible vertical fighter of the Luftwaffe. The Focke-Wulf Triebflügel was one of the strangest projects of the German Wunderwaffen in the last years of the Second World War. Designed as a vertical takeoff and landing fighter, VTOL, it sought to operate without runways constantly destroyed by Allied bombings. The craft had no fixed wings. Its central fuselage was surrounded by a ring with 3 rotating wings, on whose ends ramjet engines were mounted to drive the rotation, functioning as a rotor. This allowed it to take off and land vertically like a helicopter, but by tilting it could fly like a fighter at high speed. The vertical cockpit posed serious ergonomic problems, and it was planned to arm it with 4 cannons of 20 or 30 millimeters to intercept Allied bombers. On paper, it was a futuristic solution, but in practice it presented insurmountable technical difficulties. Controlling the transition between takeoff and horizontal flight, and especially landing in a perfectly vertical position without automatic systems, was almost impossible with the technology of 1944. The Triebflügel never went beyond models and wind tunnel tests. The plans were captured by the Allies, who studied them as an early reference for future VTOL projects. Although it never flew, the Triebflügel became a symbol of both German desperation and inventiveness, remembered today for its futuristic silhouette and present in books, documentaries, video games, and films as one of the strangest and most visionary designs in military aviation. Fieseler F-103 Reichenberg, the suicidal manned missile of the Third Reich. The Fieseler F-103 Reichenberg was one of the most desperate weapons conceived by Nazi Germany in the last years of the Second World War. It was a manned version of the flying bomb V-1, designed to be used as a manned projectile against enemy targets. Its development was driven by the need of Hitler and the Luftwaffe to find a weapon capable of reversing the course of the war when the Reich was under unbearable military pressure and its cities were being devastated by Allied bombings. The original F-103, better known as V-1 or flying bomb, had been conceived as an unmanned weapon. It was launched from ramps and flew thanks to a pulse jet engine until it impacted its target, generally London or other cities. However, in 1944 the idea arose to adapt this projectile to be piloted by human beings with the intention of achieving greater precision in the attacks, especially against strategic targets. This project received the name Reichenberg in honor of the homonymous city of Bohemia. The design of the F-103 Reichenberg was extremely rudimentary and dangerous. It was basically a modified V-1 to incorporate a small cockpit in the front with space for a pilot. The pilot had to control the craft until guiding it against the target, but there was no truly reliable escape system. Although theoretically the possibility was considered that the pilot could jump with a parachute seconds before the impact, in practice it was almost impossible due to the very high speed, the poor stability of the craft, and the short distance between the fuselage and the engine nozzle. In other words, it was practically a suicide mission. Several versions of the Reichenberg were planned, named from 1 to 5. Some were for training without explosives, so that the pilots could practice takeoff and control of the craft. The attack versions included an explosive head of approximately 850 kilograms, capable of destroying a ship, a bridge, or a fortified installation. The Reichenberg could not take off by itself, but had to be transported and launched in the air from a Heinkel He 111 bomber, which added more complexity to its operation. The group in charge of training the volunteers was the unit known as Leonidas Staffel, which belonged to the Special Attack Squadron of the Luftwaffe. These pilots were indoctrinated to accept missions that had little or no chance of survival. However, unlike the Japanese kamikazes, who were publicly exalted, in Germany this type of mission was not so well regarded even within the Luftwaffe itself. Even the famous ace Hans-Ulrich Rudel was related to the supervision of the project, but opinions were divided about the advisability of employing young pilots in this way. The Reichenberg project reflected the desperation of the Reich in 1944 and 1945. Dozens of units were manufactured and flight tests were carried out, although these demonstrated how extremely unstable and dangerous the craft was, even in training conditions. Despite the efforts, it was never used in real combat. One of the main reasons was that by the end of the war, the German military situation was deteriorating so rapidly that the Luftwaffe had neither resources nor pilots to sacrifice in such an operation. Today it is preserved as an example of how far Nazi Germany was willing to take the war to the limits of the imaginable, even sacrificing its own youth in a weapon that combined technological innovation and an absolute disregard for life. Rocket Transport Train V2, the Railways of Terror. The V2 rocket was the most advanced long-range weapon developed by Nazi Germany, a ballistic missile capable of reaching targets more than 300 kilometers away. It was the first operational missile of its kind in the world, and its deployment required a highly mobile logistical system, which included special transport trains designed to move and launch these weapons in secret. One of these trains was discovered in the decade of 1990 in the depths of the Ardennes forest in Belgium, inside a partially collapsed tunnel that had remained sealed since the end of the war. For decades, in the region circulated local legends about a ghost train hidden underground, but it was not until roadworks for a new highway project caused an accidental excavation that the place finally came to light. Inside the tunnel, the investigators found several flatbed wagons equipped with supports and cradles designed to transport the components of the V2. Although the rockets were no longer present, fragments of the launch equipment, fuel containers, and parts of the necessary infrastructure to operate the missile were found. Some sections of the wagons still retained identification codes that linked them to logistical units of the V2 that had operated in Western Europe towards the end of 1944. Historians believe that this train was abandoned during the Allied advance in the Battle of the Ardennes. To prevent the material from falling into enemy hands, the Germans could have deliberately collapsed the tunnel, or in their retreat been forced to leave it behind without time to demolish it. Today, the tunnel remains sealed for its conservation, although some parts of the train and its equipment were removed for study. The discovery constitutes a key piece for understanding how Nazi Germany tried to deploy and conceal its most devastating weapon under the cover of the European terrain. Schienenwolf, the steel plow for destroying railways. The Schienenwolf, whose name in German means rail wolf, was one of the most singular demolition vehicles employed by Nazi Germany during the Second World War. Its purpose was not to attack the enemy directly with firearms, but to destroy its infrastructure, particularly the railway lines that were vital for supply and troop movement. In a war where logistics was as decisive as firepower, this device became a tool of sabotage on a large scale. The Schienenwolf consisted of a special reinforced wagon to which was attached a huge steel blade shaped like a plow. This piece, when lowered onto the tracks, shattered the rails, ripping them up and deforming them in such a way that the railway section became unusable. The design was simple but tremendously effective. It was enough to hitch it to a locomotive, lower the blade, and drag it along the track to leave entire kilometers of rail lines completely useless. The very weight of the wagon, added to the resistance of the steel, guaranteed quick destruction that was difficult to repair. Its use intensified from 1943, when German forces began to retreat on all fronts. In particular, it was employed during the withdrawals in the Soviet Union and Eastern Europe, where the Nazis resorted to the tactic of scorched earth to leave behind the greatest possible degree of devastation. In this way, they sought to hinder the advance of the Red Army, depriving it of railway infrastructure that was essential for the transport of troops, artillery, and supplies. In some cases, the Schienenwolf was also used in France and in other occupied territories, with the same objective of complicating Allied logistics. The device was not without limitations. It needed available locomotives and fuel, two resources increasingly scarce in the final phase of the war. In addition, the process of destruction, although quick, was not completely discreet, since the activity of the Schienenwolf could be detected and attacked from the air by enemy aviation. Despite this, it effectively fulfilled its role of obstructing enemy mobility at critical moments. Today, some surviving examples of the Schienenwolf can be found in railway and military museums in Europe, where they are exhibited as a curious demonstration of how war was also fought against transport systems. It represents a reminder that in the Second World War, not only direct battles defined the course of the conflict, but also the struggle to control and destroy the logistical arteries that kept the armies alive. Goliath track mine, the explosive miniature of the Third Reich. The Goliath track mine, officially known as Leichter Ladungsträger Goliath, was one of the most peculiar and at the same time disturbing inventions of Nazi Germany during the Second World War. It was a remote-controlled demolition vehicle designed to carry explosives to specific targets, such as tanks, fortifications, troop concentrations, or even strategic buildings, and then detonate its charge. In essence, it was a precursor of what we know today as ground drones, a machine designed to replace soldiers in suicide missions. Development began in 1940, taking as inspiration a small captured French vehicle created for demolition tasks. German engineers, particularly those of Borgward and Zündap, perfected it and adapted it to the needs of the Third Reich. The result was a small, tracked vehicle just over 1.5 meters long, with a compact shape and the appearance of a mini-tank. It was built with light armor, sufficient to withstand small arms and shrapnel, and carried inside between 60 and 100 kilograms of explosives, ready to be detonated against the enemy. The Goliath was remotely controlled through a triple cable up to 650 meters long, which transmitted electricity and orders from a portable control panel operated by a soldier. One of the cables was used for detonation, while the other two were used to steer the machine forward, backward, or sideways. There were two main versions, the StKFZ 302, equipped with a silent electric motor, and the StKFZ 303, which used a gasoline engine, giving it more autonomy, but also making it noisier and more detectable. The vehicle had a relatively simple operation. The operator guided it to get as close as possible to the target and, once in the right position, activated the explosive charge to destroy it. Its effectiveness, however, depended greatly on the terrain and the tactical situation. In urban combat or against static positions, it could be devastating, but in open fields it was vulnerable. Its thin armor made it susceptible to enemy fire, and many times the control cables were cut by shots or fragments, leaving the vehicle unusable before completing its mission. The Goliath was used on several fronts, including Normandy, Italy, and the Eastern Front. More than 7,500 units were produced throughout the war, which shows the German interest in this type of weapon. Although it did not always achieve the expected level of effectiveness, it represented an attempt ahead of its time to use unmanned vehicles on the battlefield. In specific situations, such as the demolition of fortifications or bridges, it could be extremely useful. Despite its limitations, the Goliath left an important technological legacy. Its concept inspired later developments in remotely controlled weapons and robotic combat vehicles. Today, some surviving examples can be found in military museums, where they surprise by their small size compared to the magnitude of the mission assigned to them. The Goliath track mine was, in short, a symbol of German technological innovation in times of war, a machine that seemed taken from the future, but that also reflected the difficulties of transferring theory into practice in a conflict as brutal as the Second World War. Panzer E-100, the last Nazi armored giant. The Panzer E-100 was one of Nazi Germany's most ambitious projects in its pursuit of technological supremacy during the Second World War. It was part of the so-called Entwicklung program, a series of standardized tank designs that sought to simplify production and at the same time create increasingly heavy and powerful vehicles. Within this series, the E-100 was destined to be the final colossus, a super-heavy tank that rivaled the Maus and represented the pinnacle of German armored engineering. The E-100 was conceived in 1943 by the Adlerwerke company in Frankfurt. The idea was to build a tank that, although sharing certain characteristics with the Maus, would be easier to manufacture and more versatile in terms of mobility and design. Its projected weight was around 140 tons, placing it within the super-heavy category but somewhat lighter than the Maus, which reached 188 tons. Even so, the E-100 was still colossal compared to Allied tanks, such as the American Sherman or the Soviet T-34. The armor planned for the E-100 was extraordinarily thick, capable of withstanding practically any Allied projectile of the time. As for its weaponry, it was intended to be equipped with a main cannon of 150 mm, although some projects also considered the use of a 170 mm cannon, accompanied by secondary armament such as a coaxial 75 mm cannon and machine guns for close defense. This firepower would have allowed the E-100 to destroy any enemy vehicle at great distances, surpassing even the Soviet heavy tanks IS and the British Churchill. One of the greatest difficulties of the design was its mobility. To move a giant of such dimensions, it was planned to install a Maybach engine of between 700 and 1,200 horsepower, although even with the most powerful option, its maximum speed would hardly have exceeded 40 kilometers per hour under ideal conditions. Its enormous weight also complicated bridge crossing, transport logistics, and maneuverability on soft terrain, which greatly limited its practical use in rapid operations. The project advanced slowly due to the pressure of the war and the lack of resources. By 1944, with Germany increasingly on the defensive and Allied bombings affecting industry, the production of super-heavy tanks ceased to be a priority. Even so, an incomplete prototype of the chassis was built, which was captured by British troops in 1945 and later sent to the United Kingdom for study. The E-100 never saw combat, but its mere conception reflects the obsession of Hitler and part of the German High Command with the so-called Wunderwaffen, or miracle weapons capable of reversing the course of the war. In practice, the tank would have been a monster difficult to use on the battlefield, a weapon more impressive on paper than in reality. However, its design influenced later development of battle tanks and remains one of the most fascinating and extreme projects of German military engineering. Tatra 87, the Czech car that fascinated the Nazi elite. The Tatra 87 was one of the most unique and advanced automobiles of its time, produced in Czechoslovakia between 1937 and 1950 by the company Tatra. Designed by Hans Ledwinka and Paul Jarret, it stood out not only for its futuristic appearance but also for its innovative engineering, which made it a cult vehicle both for engineers and for automobile enthusiasts. Its aerodynamic design was revolutionary. The body had an elongated and fluid silhouette, with a central fin at the rear that helped with stability on the road. Inspired by the aerodynamic principles of aviation, the Tatra 87 could reach speeds of up to 160 kilometers per hour, something surprising for a pre-war car. This performance was possible thanks to its low aerodynamic coefficient and the lightness of its structure. The engine was another of its great attributes. It mounted an air-cooled V8 3-liter engine capable of generating around 75 horsepower. Being placed at the rear, it gave a different weight distribution from conventional automobiles, which influenced both the handling and its character. The air cooling, moreover, made it more resistant in extreme conditions and eliminated the need for complex radiator systems. The Tatra 87 was a car much appreciated by explorers and travelers. Its mechanical robustness and its capacity to withstand long distances made it the chosen vehicle for international expeditions, such as those of Jiří Hanselka and Miroslav Zikmund, who traveled through Africa and Latin America aboard this automobile in the years following the war. During the German occupation of Czechoslovakia, the Tatra 87 also drew the attention of high-ranking Nazis. It is known that Wehrmacht officers used it due to its speed and comfort over long distances. However, the car acquired a grim fame among the German military. Being very fast and having a peculiar behavior on the road due to its rear design, many inexperienced drivers lost their lives in accidents, which led the vehicle to be ironically nicknamed the car that killed Nazi officers. In total, just over 3,000 units of the Tatra 87 were produced, which makes it a relatively rare automobile. Its mix of technology, design ahead of its time, and the stories surrounding it made it an icon in automobile history. Today, the surviving examples are highly valued by collectors and museums, not only for their rarity, but for the role they played in the automotive engineering of the 20th century. Dornier Do-335 Pfeil, the fastest fighter of the Luftwaffe. The Dornier Do-335, nicknamed Pfeil or Arrow, was one of the most innovative and fastest aircraft designed by Nazi Germany during the Second World War. Its most distinctive feature was the configuration of its propulsion system, an engine in the front with a tractor propeller and another in the rear with a pusher propeller. This arrangement, known as push-pull, eliminated much of the aerodynamic resistance present in other twin-engine fighters and gave it speed and performance superior to almost any Allied aircraft of the time. The Do-335 was powered by two Daimler-Benz DB603 engines, each of 1,750 horsepower, which allowed it to reach speeds close to 765 km per hour, making it the fastest piston fighter produced in series during the war. In addition to its speed, it had a much greater flight range than most conventional fighters, which made it suitable both for heavy fighter missions and for fighter-bomber missions. Its armament was equally formidable. It was equipped with an Mk103 30mm cannon firing through the axis of the front propeller, accompanied by two Mg1 151 20mm cannons mounted in the wings. In the ground attack versions, it could carry bombs in an internal bay, maintaining its aerodynamics without sacrificing speed. This combination of firepower, range, and speed made it potentially devastating in the hands of experienced pilots. The design also incorporated advanced safety solutions for the pilot. Since it had a rear propeller, Dornier implemented a pioneering ejection system. Before the seat was shot out, the tail of the aircraft was expelled and the propellers were released to prevent the pilot from being injured. This made it one of the first fighters with a truly functional ejection system. However, the Do-335 arrived too late. Its first flight was in 1943, and the serial production barely began in 1944, when the Luftwaffe was already weakened and lacking resources. Only about 37 units were manufactured before the end of the war, too few to influence the course of the conflict. The pilots who tested it confirmed that its performance was impressive, far superior to that of most Allied fighters. But the shortage of fuel, the bombings on factories, and the chaos in German production made its large-scale deployment impossible. After the war, several examples were captured by the Allies for testing. One of them, the only one that survived in complete condition, was sent to the United States and today is preserved restored in the National Air and Space Museum of the Smithsonian in Washington, D.C. The Dornier Do-335 Pfeil represents the culmination of German engineering in piston aircraft, a design ahead of its time, with innovations that marked the transition towards jet fighters. Although it did not change the outcome of the war, it is still remembered as one of the most extraordinary aircraft of its era, a machine that combined power, speed, and futuristic vision in the final moments of the Third Reich. Fokker-Achilles Fa-330 Bachstelze, the strange autogyro of the Nazi submarines. The Fokker-Achilles Fa-330, known as Bachstelze or wagtail, was one of the most unique and unconventional aerial devices employed by Nazi Germany during the Second World War. It was a kind of rotor kite, a manned autogyro designed to be towed by German submarines on the surface. It was not a helicopter in the strict sense, since it had no engine of its own. The rotation of its rotor depended on the forward movement of the submarine, which allowed an observer to be lifted to more than 100 meters in height. The purpose of the FAR 330 was to extend the observation range of the U-boats. From that elevated position, a lookout could see up to 40 kilometers in all directions, much more than was possible from the submarine's tower. Its structure was extremely light, built with aluminum tubes, a canvas seat, and a two-blade rotor. In addition, it was designed to be disassembled and folded quickly, which allowed it to be launched or recovered in a few minutes. However, the use of the FAR 330 implied a great risk. When deploying it, the submarine had to remain on the surface, becoming vulnerable to enemy air and naval attacks. For this reason, its use was limited, and it was employed mainly in areas where the Allied threat was lower, such as the Indian Ocean. In total, about 200 units were built, but only a few were deployed regularly. After the war, most of these devices were dismantled and fell into oblivion. However, in the decade of 1970, a practically intact FAR 330 was discovered in a former Luftwaffe testing field. Despite the passage of years, its simple and fragile structure had been preserved in good condition. Today, the surviving examples are extremely scarce. One of them can be seen in the National Air and Space Museum of the Smithsonian Institution in the United States, while others are found in aviation museums in Germany and the United Kingdom. Although it never had a decisive impact on the course of the conflict, the FAR 330 Bachstelze remains a fascinating example of German experimental ingenuity. It represents a stage in which even submarines were equipped with aircraft, a reflection of Nazi Germany's drive to seek unconventional solutions in its technological war. Messerschmitt Me 323, the colossus of the German skies. The Messerschmitt Me 323 Gigant was the largest land transport aircraft employed during the Second World War. Its design derived from an earlier model, the glider Me 321, to which 6 radial engines were added, allowing it to become a powered aircraft capable of transporting colossal loads for the time. It could carry between 10 and 12 tons of equipment or around 120 fully equipped soldiers, becoming a key piece within German logistical plans. The Me 323 was conceived to accelerate the deployment of troops and materials in large-scale campaigns, such as the invasion of the Soviet Union and the operations in North Africa. However, this impressive capacity came with serious limitations. It was a slow aircraft with minimal air defenses and extremely vulnerable to enemy fire. These weaknesses became evident in 1943 when several of these giants were shot down by Allied fighters over the Mediterranean while transporting troops to Tunisia. Throughout the war, most of the Me 323 were destroyed in combat or scrapped after the conflict, which contributed to none of them being preserved complete. However, in 2012, a remarkable discovery occurred. Off the coast of Sardinia, in Italy, divers located the partial remains of a submerged Me 323. Among the wreckage were identified sections of the fuselage and the enormous struts of its wings. The site was later confirmed thanks to historical flight records and serial numbers recovered in the area. Today, although no complete specimen exists, some parts of the Me 323 are preserved in museums. The aircraft remains as a reminder of the technological ambition of Nazi Germany, which sought to solve its logistical problems through the construction of colossal machines. Nevertheless, its history also reflects the limits of this strategy. Size and load capacity were not enough against skies increasingly dominated by Allied fighters and bombers. Blohm & Voss BV-141, the reconnaissance with an impossible design. The Blohm & Voss BV-141 was one of the most unusual designs of German aviation during the Second World War, conceived as a tactical reconnaissance aircraft. Its most striking feature was its asymmetrical configuration. Instead of having a central fuselage, the BV-141 had a glazed gondola located on the right side of the aircraft, intended for the crew and observation equipment, while on the left side was the radial engine and the main fuselage. This unconventional arrangement offered observers an exceptional panoramic field of vision, something crucial for reconnaissance missions. The design was developed by the company Blohm & Voss under the direction of engineer Richard Vogt and it was a bold attempt to solve the problem of visibility in reconnaissance cockpits. While most aircraft of the time suffered from vision limitations due to their structures, the BV 141 offered an almost completely glazed cabin with frontal, lateral, and rear vision without significant obstacles. The prototype flew for the first time in 1938 and surprised evaluators with its stability and maneuverability despite the strangeness of its design. The asymmetry, far from being a problem, turned out to be carefully calculated to maintain aerodynamic balance. However, the aircraft faced an insurmountable obstacle. The BMW 801 engine, which was supposed to equip it to achieve maximum performance, was in great demand for the Focke-Wulf FW 190 fighter. As a result, the BV 141 had to settle for less powerful engines, which seriously limited its performance. In total, around 28 units were built, including prototypes and production versions, but it never reached mass production. The Luftwaffe High Command chose to continue with other reconnaissance models, such as the Focke-Wulf FW 189, which was more conventional and easier to manufacture. Although the Blohm and Voss BV 141 never entered large-scale service, its design became an example of extreme innovation and the boldness of German aeronautical engineering during the war. Today, no specimen is preserved, but the BV 141 continues to be studied and remembered as one of the strangest aircraft ever built, proof of how the search for innovative solutions often led to designs that seemed taken from science fiction. Borgward IV, the remote-controlled tank of the Third Reich. The Borgward IV was a remote-control vehicle developed by Nazi Germany during the Second World War, designed specifically as a remotely operated demolition tank. Unlike other similar devices, such as the small Goliath, the Borgward IV was larger and equipped to transport much more powerful explosive loads, which made it one of the most advanced weapons within the category of remotely controlled demolition vehicles. The vehicle weighed approximately 3 tons and 600 kilograms and was armored with plates that gave it some protection against light weapons fire and shrapnel. Its design included a robust track and a low structure, which allowed it to move across difficult terrain and approach enemy positions without being easily destroyed. Unlike other models of self-propelled mines, the Borgward IV was not designed to explode along with its load. Instead, it carried a container of up to 500 kilograms of explosives at the front, which could be released near the target by remote control. Once the load was deposited, the vehicle could retreat, which allowed it to be reused in multiple operations. The remote control system was initially carried out by cable, but in later versions a radio control was implemented, which offered operators greater flexibility and safety. These vehicles were guided toward fortified positions, minefields, or even against enemy tanks, with the objective of destroying heavy defenses or opening the way for German infantry and armored vehicles. However, the Borgward IV had limitations. Although it was better armored than the Goliath, it was still vulnerable to enemy fire and aerial bombings. In addition, its handling was complex and costly compared to other demolition devices. In total, more than 1,000 units were manufactured between 1942 and 1945 in different improved variants that sought to increase their effectiveness. The Borgward IV was employed in several campaigns, including the Eastern Front and the defense of Normandy. While it achieved some specific successes in the destruction of fortified positions, it did not have a decisive impact on the course of the war due to its vulnerability and the rapid advance of Allied forces. After the war, some specimens were captured and studied by the Allies. Today, few units are preserved in military museums, where they are remembered as an example of the German attempt to combine mechanical engineering with the concept of mechanized remote-controlled warfare. The Borgward IV represents one of the first steps toward what decades later would evolve into the development of unmanned military vehicles. Kfz 251, the German half-track that brought troops to the front. The Kfz 251 was one of the most emblematic and widely used armored vehicles by Nazi Germany during the Second World War. Designed by the company Hanomag, this half-track combined the mobility of a wheeled vehicle with the off-road capability of a tracked system, which made it an ideal transport for the German mechanized infantry, known as Panzer Grenadiers. Its development began at the end of the decade of 1930 in an attempt to provide the troops with a protected means of transport that could advance at the same pace as tanks. The result was a vehicle of about 8 tons, with armor that varied between 6 and 14 millimeters, sufficient to resist light weapons fire and shrapnel, but vulnerable against anti-tank weapons. It could transport up to 12 soldiers in addition to the crew, normally composed of a driver and a commander. The design of the SDKFZ-251 was open at the top, which made it lighter and easier to produce, but also left the crew exposed to aerial and artillery attacks. Despite this limitation, its versatility was one of its main virtues. Numerous variants were manufactured, equipped for different tasks: troop transport, command post, communications vehicle, flamethrower, ambulance, light anti-tank gun, rocket launcher, and even platforms to launch missiles. In total, more than 15,000 units were produced during the war, which made it one of the most manufactured armored vehicles of the conflict. The SDKFZ-251 accompanied the Panzer divisions in all campaigns, from Poland and France to North Africa and the Eastern Front. It allowed the infantry to advance under some protection and reach the battlefield directly alongside tanks, implementing more effectively the doctrine of blitzkrieg. However, its production required more time and resources than that of similar Allied vehicles, such as the American M3, which limited its availability compared to the real demand of the German army. At the end of the war, many of these machines were abandoned or captured by the Allies, who in some cases reused them. Today, several restored examples are preserved in military museums and private collections, where they remain a reminder of the German attempt to mechanize its infantry on a large scale. The SDKFZ-251 was not invulnerable nor revolutionary in terms of protection, but it was essential for the mobility of German forces and remains a symbol of the mechanization of modern warfare.